Hi, my name is Julie Hoyman, and I'm a third grade teacher at Powell Elementary School. I'd like to say a great shout out to my Panthers and welcome everyone else to science. This activity is Activity 3 for science. It's the summer activity. The activities in the handouts can be found under the Student Resource tab on the Knox County Schools website. You can also show us what you've learned by tweeting us at KCS Science. If you have a hard time understanding this video, there are a few tips that can help you out. Turn on the closed captions. Adjust the feedback speed to slow down the video. Consider watching short clips, pausing, listening, and watching again. You could also ask someone in your home to watch the video with you. Stop frequently and talk with your partner about what you have heard and what you have understood. Now, let's get started. Today we're going to be learning about energy. Well, I have 3 friends, and they were setting the table for lunch, and one dropped a cup of milk on the floor. They started talking about the spill that the milk had made on the ground. They started wondering about the size of the spills. Julian said, "No matter where you spill milk from, it will just be the same size spill. It's the same amount of milk." Emily said that the milk dropped from a higher place, like standing, will make the larger spill. Caleb said that the milk knocked over on a table would spread out even more. Find the first box on your handout. Take a minute, stop and think, and write, who do you agree with most and why? On your handout, you will see the friends we are talking about, and you will also see some lines where you can write who you agree with and why. Pause the video and do that now. After this video, you will understand who is correct and why they're correct. Our essential question today is, what makes things move? Energy is the ability to make things happen. Energy is all around us and can come in different forms. It is a concept used by engineers who design the products and the technology that we use every day, like phones and video games, roller coasters, and so much more. So what is energy? Let's explore energy with something you might be familiar with. Can you think of a time when you or someone else put something up high? What about one end of an object higher than the other, and you repeated it over and over again? Did something special happen? The way that one thing knocked over another into another, and so on? Did you think of dominoes? And what type of energy are in dominoes? As I said, energy is all around us, and it comes in different forms. Have you ever heard of potential and kinetic energy? Let's explore these scientific words. When you stand up a domino upright, it gives it potential energy or stored energy based on its position. Potential energy is like when your teacher says that she thinks you could do something, but you haven't done it yet. So it's kind of like that domino. It hasn't done anything just yet. The energy is stored and is able to be used later. When the domino falls, much of the potential energy is converted into kinetic energy, the energy of an object that has motion, because of its motion. A domino hits another and another until you run out of dominoes. A falling domino converts its potential energy to a kinetic energy, the energy of movement. Potential versus kinetic energy. That's like having a skateboarder that moves up and down a ramp. Her energy goes back and forth between potential energy and kinetic energy. In this activity, you were introduced to both potential and kinetic energy. We will see how engineers use this idea of transfer of energy in real life. Now, let's be scientists. We want to answer a question: what makes things move? In this activity, you're going to drop water from different heights. Will the height of the water affect the amount of kinetic energy? That's what our three friends were talking about earlier. Next, make a prediction. Stop the video and make that prediction on your handout. To do this experiment, you're going to need some things you can find around the house. You can see the list here or on your handouts. The materials you need would be a 1/4 teaspoon or a regular spoon 1/4 full, a cup to hold water so you don't have to keep walking to the sink, a measuring stick or a measuring tape, pencil or a pen, and 2 pieces of paper or construction paper. To carry out this investigation, we're going to have several steps, so why don't you take a minute, pause the video, and go find the things you're going to need. Now let's carry out the investigation. First, fill a small cup with water, so you won't have to keep going back and forth to the sink. Second, fill a spoon with 1/4 teaspoon of water. Third, you're going to drop that water from 6 inches and immediately draw a circle around the splash. Do it immediately, because if you wait, the water will get soaked up into the paper. Fourth, you're going to measure the diameter of the splash. In other words, measure the distance from one edge of the splash to the other. Fifth, record your data in the chart below. Now, sixth, you're going to be repeating the investigation, but for a different height, the height of 24 inches. How did it go? Did you measure and drop the water? Then measure the diameter of the drop? Did you use the next box to draw or write about the results? If not, pause the video again and do that now. Now, think back about your prediction. Take some time and see how your prediction compared with the results of the experiment. Let's look into what happened. Just in case you didn't have a chance to do the experiment, here are my splashes marked out on paper. You can see that the higher the water was dropped from, it caused a much larger splash. We can prove that the water height does affect the amount of kinetic energy. We are using water to recognize how energy is transformed in motion. This is a fun process, and it happens every day in hydroelectric dams here and around the world. But how does it work? In the experiment, you discovered that as you placed height to the water, you added storage energy in the object. This scientific discovery supports Emily's idea about the milk. She said that milk dropped from a higher place, like standing, will make the biggest splash. This is just like the upper reservoir in a hydroelectric dam. This is the potential energy. The water falls with the transfer of kinetic energy. The energy is moved. The force of the water that is falling spins a turbine at a low speed. The engineers want this to happen so the fish don't get stuck in the turbine and are safely passing through. The turbine causes the generator to start working. Inside the generator, a shaft spins coils of copper wire inside a ring of magnets, creating an electrical field and producing electricity. The energy moves from one object to another as the water moves the turbine within the dam. This movement of the turbine will create the electricity that is sent to homes and businesses within your community. Thank you for joining us today on energy. Specifically, what makes things move and how energy transforms from one object to another, like water dropping, turning a turbine that creates electricity. I'm Julie Hoyman with Knox County Schools Science Department. Again, please share your findings and your pictures by tweeting KCS Science. And thanks again for learning with us. Have a great